Okay, grade 10s, you made it. Congratulations. I have a huge smile on my face. I'm so happy for you guys. First of all, thank you guys for, your patience, your effort, dealing with all of this new kind of learning environment from a distance. All your efforts are just, we're so appreciative of you guys hanging in there. And I know so many people are dealing with lots of different situations right now. So you're in our thoughts and prayers, but hopefully you guys got something out of our, past number of months together, even with our new format. I don't want to make this too long. Let's get into our last lesson. I don't think I need to spend a lot of time on this one because I already kind of covered this when we introduced systems of equations. So, the very last section in our textbook is 7.6, and it talks about like the properties of linear systems of equations and how many solutions you could possibly get. So, without further ado, I'll just skip kind of along. Basically, when you graph different things, let's say you use your graphing calculator or you graph them by hand, most of the time you have to turn them into y equals mx plus b form, right? You have to put both your equations, y1 and y2, into this format because it's the easiest to graph. And in fact, in your graphing calculators, that's the only format they accept for you to punch in your top left button. You have to have y equals alone, your dependent variable alone. So you're going to get an intersection, right? And 99% of the time, because these are straight lines and they usually have different slopes, you're going to have one intersection, -2, -1. That means you have one solution. But what if you ever graphed or rearranged and then you realized that, you graph something and they have the same slope? Well, if they have the same slope, that means they're parallel. They will have no intersections. That means there's no solution. So most of the time, you're going to have one solution. But if they're ever parallel, see they have the same slope. As I said, they're going to have no solution. So that happens sometimes. Even more rarely, when you convert both of your lines into y equals mx plus b form, if you actually do that, you'll realize, like this example down here, in fact, if you just divide the bottom line, if you divide the whole thing by 2, it ends up matching the whole thing. So if you see your y equals mx plus b, and your second line, y equals mx plus b, are the exact same, then you're not going to have one solution. You're not going to have no solutions. I know it's hard to see on this textbook, but these lines are actually on top of each other. They have infinite solutions. So you could possibly have infinite solutions because these guys cross or intersect infinite amounts of times, assuming these lines extend forever, right? We call those lines coincident lines because they coincide exactly with each other. But we already knew that because I introduced that the first one. So the key to look for, though, is most of the time, basically, I'll give you a shortcut. If you have different slopes, when you do your y1 and your y2, as long as you have different slopes, automatically you have one solution. So there's your shortcut. Look for different slopes. You're going to have no solution if you have same slope. So in other words, when m1 equals m2, but you technically also have different y-intercepts or different intercepts here. Okay, so same slope but different intercepts, you're going to have no solution. Because same slope means they're parallel. But you have to have a different y-intercept clearly so they cross. This one, you have the same slope and same y-intercept. In other words, the equations are identical. Whoops, sorry, it's off of the page. Same slope and same y-intercept. In other words, identical equations. If you have identical equations, then they have infinite solutions. So, different slopes, one solution. Most of the time, you're going to get that. If these ones have the same slope, but a different b value, for example, so different b value, you're going to have no solution. If you have the exact same slope and the exact same b value, it's the same line, therefore infinite solutions. I think that's pretty much it. So they give you some examples. So the best thing to do is turn all of these into y equals mx plus b form so you can easily compare them. That's what I would do if they were asking me for how many times do they intersect. because that's really all number of solutions means, is how many times do they cross, how many times do they intersect. So turn them all of these 6 into y equals mx plus b form, and then you can judge. For the first one, I'll just try to highlight it. So they gave you just random forms. So you would minus the x over here to the other side. That would look like this as your first equation. The bottom equation, they added the 2x over there, and then they have to divide by -2. Long story short, they get y equals to negative x minus 2. Oh, guess what? Your top line and your bottom line are the exact same. Therefore, they're coincident, or they have infinite solutions is your answer. Once again, exact same when you return them to y equals mx plus b form. Therefore, infinite solutions. Simple. In question B, again, get your y's alone, so move your x's over there, so minus 4x, or add 2x to that side, and then divide by whatever the coefficient is. Here you divide by 6, here you divide by -1. And if you do that, one of your equations is y equals -2 over 3x minus 5 over 3. The other equation is way over here, y equals -2x plus 1. Here, you can see all you have to look at is the slope. One of them is -2 over 3. The other one is -2. So different slopes, automatically you know there's going to be one solution. So therefore, you have one solution. Last example, again, turn them into y equals mx plus b form. One of them, you get y equals -3x minus 6. Oh, the other one was already in y equals mx plus b form. Notice they have the same slope of -3, different intercepts. That means they're parallel lines. So they have no solution, so therefore no solution. Perfect. There's a summary of them down there. So one solution, again, you have different slopes. That's the key to look for. This one, you have same slope for y1 and y2, different b value. And this one, you have the same slope and same b or y-intercept. All right. So obviously turn them into y equals mx plus b form to do that. And then the second example, you just have some creativity. You make your own equations where you'd have either 0, 1, or infinite solutions. So obviously, if you want one solution, which is the most common, you just make different slopes on your, so just make one of them like y equals 3x minus 5, and one of them 2 over 5x plus 4. Good. Different slopes, you're always going to have one. If you wanted 0 solutions, you just make the slopes the same, different intercepts. And if you want infinite solutions, make the slopes the same and the b's the same. Done. I'm not going to force you guys through that because you guys have worked so hard, and I'm sure you want to just wrap it up. So I know it wasn't perfect, and you had to sit through a lot of my boring videos over the last few weeks, but again, thank you guys so much. Please, as usual, don't be afraid to reach out to me if you guys have any issues or questions. Good luck wrapping up your summary for Chapter 7, and we're going to start doing some review for the whole year, and that's it. We're done. We're ready for the summer. All right, guys, take care. God bless.